Basic database concepts. Before we can begin to work with SQL Server as our chosen database product, we need to, so in this nugget, we're going to take a look at several topics that will give us this foundation. We're going to start with the topic on database fundamentals, typical objects you would find in any database and what are those used for. We'll then move on to our topic on relational design basics. Now, and we'll begin to kind of conceptualize what our design process would be for building a database. Now, the reason that this is very important is because if we're going to be working with data, then we'll move on to our topic on normal form. And normal form gives us a set of rules that we can follow to end up with a good solid relational form and what the rules are associated with each level. We'll then move on to our topic on relationships. Now, if we say that SQL Server is a relational, so we'll take a look at the types of relationships that we have to work with and why we might want to use different types of relationships in different situations. Topic in this particular nugget that's going to be technology specific. The Northwind database is a sample database that exists in one form or another and while the two versions of the database in each product vary slightly, we're going to take a look at the basic table structure that exists in the Northwind database at point. Okay, let's go ahead and start with our topic on database fundamentals. So our first question is, what is a database? For storing data. And it also provides a common access method for being able to retrieve that data and the ability, of course, to repository. And that repository providing us a standard access method base. You will find a variety of objects. And we're going to be talking very specifically about the objects you would find in a SQL Server database in a later nugget. So indexes and the ability to create queries. So what is a table? A table is really nothing more than a structure that allows it is going to contain columns and rows, and we can think of it much in the same way that we think of as a spreadsheet. In other words, we have columns and rows, and we're a column and a specific row. Now, in addition to having tables, we also have the ability to have index structures. And index structures give us the, you think of an index in a book. You go to the back of the book and you want to find every instance of a particular word throughout all the text in the book. And it tells you exactly what page. You make a request for some data, it checks its index structure, and it finds out where that specific piece of information resides. So you can really think of an index to a specific record when we're trying to retrieve data. And then our last item here is a query. And a query is our standard access method for retrieving data as well as the ability to update data. Well, a query allows us to do this. A query you can think of pretty much as being you're questioning the database, saying what salespeople last year had sales over a specific dollar amount, or who were my best customers last statement to the database product that will tell the database product exactly what information you'd like to have back. We can also use queries a particular record that exists in the database. Now, to understand a relational database, we really need to have a good foundation in the basics on design basics, relational design basics, and we're going to first start with a comparison of a relational database to a flat file system spreadsheet scenario. Let's say, for instance, you're using Microsoft Excel and you have a worksheet and you want to store information about, let's say, your CD collection. This is not to create a database that contains all the information about all your music CDs. So in this spreadsheet, you would go through and you would end up with a very wide, because you're going to have columns to store information such as the artist's name. You're going to need to be able to store information about who his record producer is. You might want to store information about his agent. You may want to store information about every single song that's up with a very, very wide file. Now, the problem with this is that the information is rather difficult to work with at this point. In other words, we have as being a single record, and then if we want to reuse this information, how are we going to go about doing that? Now, Excel does in previous cells, but what if we want to take that information and reuse it on a different worksheet? What if we want to take that information and somehow relate it to work with, beside the fact that we end up with a row of data or a record that could be hundreds of columns wide, and it becomes confusing, the artist to the various things that are defined in this flat file. And this flat file, of course, doesn't have to be an Excel spreadsheet. It could be a text file in a delimited or pipe delimited format. So the alternative to this is to work with a relational database and a relation into smaller groupings that are easier to work with. So, for instance, we could create an artist table and put information specific to a producer table, and put information that's specific to the producer of an album in that table, and then create relationships from both the producer and the artist to this album table to define how this information or how they work together, or how we can kind of conceptualize them. So the first thing that we need to do, if we're going to go through and actually design a long line of text, what we're going to do is we're going to use a relational design that is more vertical in nature rather than horizontal in nature. In other words, we'll store many producers in separate tables and then create relationships between those tables so that we end up with tables that are not very wide. So let's talk a little bit about what entities are. Defining entities is our very first step in creating our relational database design. Then break that down into smaller components, and we can refer to these as entities. Let's say, for instance, that you're creating a database and it's going to track, you have a bunch of students that are taking classes from instructors, and they're assigned to go and take these classes in particular classrooms. So we're going to store various information about our instructors, such as their name, their experience, maybe whatever background they might have that might be pertinent. And in this case, we're going to be storing information about the student, where they are with whatever training program they're, a variety of pieces of information about the student. And then the last piece that we might store would be information about the classrooms, because let's say that a particular classroom has a certain number of items in it that can be used to facilitate the class, such as an overhead projector, or want to store specifically about the room. So in this case, we have our basic structure for our database. We know we need an instructors table. So let's take a look at another example. Let's say, for instance, that we're a company that buys and sells products. And we have customers. That sounds like an entity. And then we sell products. That sounds like an entity. Products. Well, at this point, of course, orders becomes an entity. And how can I easily tell what my entities are and pick out the nouns? So we know that we have customers who are going to buy products from us, and they're going to buy these products via placing orders. This takes care of defining what tables we need to have in our database. Our next step is to define what columns should exist, and you want to have the customer name, maybe the customer address, that type of thing. How about the products table and the orders table? And once we have these various columns, exactly a product description column, or should that exist in the products table? Now, some of this may seem very obvious to you at first glance, but you will find in going through not quite so clear exactly where the column should reside. Now, to help us with this, we have some rules that we can use, and this is referred to as normalized. So, let's go ahead and jump over to our topic on normal form. We're going to start out with our first normal form. The first one is that we can have no duplication of data within a row, and the second is that each row must have a unique identifier. Okay, so we're a non-normalized set of data. We have this first row or record of data where we have a room number, which is going to be Bob, Jane, and Steve. And then for room 11, we have a student called Sue, a student called Paul. Okay, so we don't want to have any duplication of data within a row, but we actually do. We have duplication of student information within the same row. In other words, we have room 8 in a flat file scenario, or if you were going to record this information in an Excel spreadsheet. Now, in a database, we don't want to do it that way. Remember that instead of being horizontal, we could create a table that has our room number and then our student and our room number. Then we have Paul in room 11. Now, at this point, is this table normalized? Well, no, not really, but form. What it does is we now are no longer duplicating student information within the same row of data. We're now again and then student names. Now, the other consideration we have for first normal form is that each row must have a unique identifier. So we could use the room number column as our unique identifier, but we really can't because we have two rows with the same number of 8 identifier. In other words, room number 8 and Bob is unique, room number 8 and Jane is unique, 11 and Paul is unique. Well, that's great in room 8 with the same name. What if there were 2 Bobs? So now the problem you have is it's not unique. So a better way to do this, and actually part out to a separate table, and then enter that student ID, which is going to be a unique number, room 8 and room 11. And we have student ID values. So Jane has a student ID of 345, and Paul has a student ID of 456. Now, by using student ID values here, or these two columns combined together create a unique identifier, because there's no way that we can have the same student in the same, but we also have to include the room number to make this unique, because the student could also be assigned to other rooms. Let's say Bob, for instance, was also taking a class in ID and the room number to make sure that we have a unique identifier. Now, another method we could have used for this, of course, is we could certainly have just created and then specified unique IDs in this particular column to make sure that we have a unique identifier as well. Just saying that every single row in your table has to be unique, and there has to be something about it that's unique, and that can be either an ID column where we can use combinations of columns to define that that row is unique to every other row in the table. For instance, our combination of our room normal form set of rules. And the first rule that we have is that we must meet first normal form. In other words, we have to meet the rules that we have in F. And then in addition to that, we can have no duplication of data across rows. Now, let's go ahead and take a look at, and in this case, we have some shipping information, and we have a shipper. They have an address of 123 Main Street. Order 321. This also took place on January 1st of 2001. And then, of course, at 123 Main. Okay, now, if we can't have duplication of data across rows, then we have a problem here, because we have address information for every single order that we enter into our database. So the second half of our rules for second normal form help us with that via a foreign key. So let's say that for order number 218, we still want to store our order date information, in this case shipper 1, because shipper 1 happens to be ABC Shipping. There, of course, at 123 Main Street. Okay. And that, of course, also took place on January 1st. And we can just specify a shipper number of 1. And then what we need are order table, where our order information is stored, and our shippers table. So we've taken the data that existed here as duplicated data, which has to be duplicated from one row to another, is purely the shipper number. And then we can create a relationship via a foreign key. Now, what is this in a foreign table? Now, when we say primary key, the shipper number in this case is our primary key for our shippers table. It represents to have something that represented every row as being unique. In this case, we're using a shipper number column, or we could say shipper ID. And shipper number or shipper ID column in our orders table, and we specify whatever the shipper number is in that table, and this becomes a foreign key in a foreign table. Now, once we've met all of these rules, our next step would be to take a look at first have to be in first normal form and second normal form. But then in addition to that, all the data that's contained in our database must be completely dependent upon the look at a quick example of a classroom where we're tracking information about female and male students. So let's say we have class numbers for a total of 14. And class number 32, and it has 12 students, male students, 4 female students. Take a look at our rule for third normal form. Our data must be completely dependent on the primary key. Well, our male student information is dependent upon class 1, which is our primary key in this table. We could have said class ID if we wanted to, but this is the ID column that makes every single row in this table unique. It is not dependent upon class number 21 at all. It's actually the addition of the number of male students and the number of female students. So, particular column, because we can always go through at a later date and calculate our total by simply adding up the total for this particular class. Other types of columns that we could end up with that are not dependent upon the primary key would be any gone through and used a combination of information to come up with a result, not necessarily mathematic. Also, instances where we've included columns rely on that specific primary key. And there we have our rules for normal form. Keep in mind, first normal form means the identifier of some sort. Second normal form tells us that we have to be in first normal form, plus we can have no duplicate data across rows, and then create a relationship via a foreign key value. And we'll take a look at relationships in just a minute. Then third normal form.